Okay, in this tutorial, not only are we going to keep working with this right triangle, we're going to make it a little bit bigger, but we're also going to start really taking advantage of some of the more powerful tools built within Blender. I mean, this is really, really important. I can't tell you how important this is for your work. If for those of you who are doing maybe CAD or architecture, or want to be a technical artist and need to have accurate measurements within your scene. So in the past you've seen me just pull up the regular calculator to show the work, but we don't need to do that. We actually have calculator features built right into Blender. Alright, so let's just upgrade this triangle a little bit. So instead of being a triangle that has a hypotenuse of length 1, let me see, I have another triangle hidden in here somewhere, so I'll go find it. There's that one, and I'll hide this little one instead. Alright, I'll get rid of that, and then I'll change these. So I know these are going to end up being length 1. Alright, so there are my lengths like this, 1, 1. And now what is this length? Well, of course, that's going to be like the previous tutorial. We'll just wing through that real quick. So there's going to be a squared plus b squared is c squared. Well, a is going to be 1 squared, right? And then b is going to be 1 squared. And c is going to be, well, that's going to be is equal to c squared. So this really becomes 1, and that becomes 1. 1 times 1 is 1, and 1 times 1 is 1. So c squared is equal to 2, like this. So then we take the square root of both sides like we did in the previous case, and then c becomes equal to the square root of 2, like this. I actually haven't taken the number on it, though I could take the square root of 2 to do it, but a lot of times you'll actually see these triangles listed as 1, 1, square root of 2, like that. Alright, a lot of times on the hypotenuse side, on this side length triangle, they don't show it. You'll see this show up in trigonometry a lot. Alright, so if you have others, lengths, they'll take these two lengths and they'll take the square root of this side, and here they are taking the square root of this side, but they're just leaving it in that form without actually calculating it out. We could actually take the square root of 2 like this, and it'd be 1.414 like that. So you might see it, but most of the time it's left in this format. However, really wanted to point out though is what's really great about Blender. Well, there's so many great things about Blender, it's just unbelievable. To calculate this triangle, let's say the length of this triangle here, you can come into this side, type it in right here. Now I'm working in the metric system. Recall, that's how I like to work. Over here in this button I have the metric set and radians set like this. So this is important to know based on what you're using. I'm working in radians, and I'm going to show you how powerful Blender is because of this. Let's say I want to go back and make another triangle that's a unit that has a hypotenuse of 1. For this long triangle, this is really, there's the hypotenuse on this triangle like this. But if I wanted to make a smaller triangle again, well, I want to know, of course, what the side is of the triangle. So maybe I'll take this one, I'll just copy it into place, Shift D. So now I still have this one here. I'm going to change this one now. So I'm going to change it back so it has the sides associated with a 45-degree angle. Well, then I would have to get my calculator, take the sine of 45 degrees, or in radians, that would be, sine of pi over 4, or 0.785 radians, and then I'd take those numbers, and then I'd enter them in here, and I'd get my dimensions along x for cosine and then y for the sine. But you don't need to do all that. You can actually type in expressions directly into these fields right here, and that's really the only way to work. Well, not the only way, but it is a very, very powerful way to work. So for instance, if this is going to be the y side of my triangle, and it is because you can see my axis is set and I'm in local axis mode, so I know that's the sine. This is going to be my sine dimension like this. So I'm just going to come in here like this, and I want the sine of 45 degrees. I'm going to say sine, and I can't say 45 degrees because I'm working in radians, but I can say sine of, well, actually let's make it simpler. We know that this is pi, halfway around the circle, and we know it's pi divided by 2 for a quarter of the circle, and this is going to be pi divided by 4, 1/4 of the angle to pi. So I can literally just type that in my expression. I can type in sine with open parentheses and the word pi, and a division symbol with a slash, and 4, and then I type that in, and it instantly calculates it for me. It's like I'm using a calculator for my expression, and it gives me the result. Now notice it shows it as 70.711 instead of points, but it's because it's indicating it in centimeters. Another value of the metric system is if I wanted to represent it as meters, it's just 2 decimal points over to the left, like this. And the same thing with here. I want to get the x distance. I'm just going to be the cosine of pi divided by 4, and I put that in, and suddenly I have the length and the width of a unit of a triangle that's based on a unit circle. I'm going to have to move this, of course, to back to the G shift Z. In fact, there's a way I can do that without even doing it. If I change this point for my origin, if I put my origin down to here, then when I change that, I could actually scale it accordingly. So let me put my cursor to the center, make sure it's generally lined up. Alright, so there I am back to this triangle that has a hypotenuse of length 1 now, like this, and these are going to have to change back to the other values from before. Alright, so it's still a 45-degree angle, but that is the point, is that in here, use these expressions to your advantage, because it's how I actually will build my models in the scene, by entering in my dimensions via a calculation without having to take the extra step. Alright, powerful and really cool. And that's it for now, and I'll see you in the next lesson.